So far in this section, we've been looking at data where we've collected information about one variable. So, for example, the number of Skittles in a packet or the temperature in Leeds. But often we collect more than one variable about each subject, and we're interested in relationships between those variables. So, for example, I might collect data on what score students get in this course, MATH1710 Probability and Statistics 1, and I might also collect data on what score those same students get in MATH1712 Probability and Statistics 2. I might be interested in if there's a relationship between a student's score in 1710 and in 1712. For example, is it the case that students that do well in one also do well in the other? So here we're thinking of collecting multiple measurements or multiple variables from the same subjects. So we can think of this like this. Instead of having a single variable, x, being x1, x2 up to xn, we've also collected another variable, y equals y1, y2 up to yn. But crucially, these are collected about the same thing, so the results are kind of paired, as in x1 and y1 correspond to one another, like they're the same person's two exam scores, and x2 and y2 are paired, and xn and yn are paired. So it's not just we've collected one data set and then we've gone and collected some other data set. It's that they're paired because they're measurements about the same subjects. So here's one example of this. Let me explain first what the data is and then explain what the picture is. So here I've collected data about the general election scores, general election results in the US presidential elections in 2016 and 2020. And for each state, there are 50 states in the US. I've collected XI, that state's Republican percentage in 2016, where Donald Trump ran against Hillary Clinton, and then also that same state's Republican result in 2020, when Donald Trump ran against Joe Biden. And so what I've drawn here is what is known as a scatter plot. And so on the x-axis across here, that's the 2016 vote. So where the Republicans got more than 50%, they won that state. And here on the y-axis, we've got the 2020 vote. I've also put in some lines at 50%. So if you look at this bottom right quarter, those states there are the ones that Donald Trump won in 2016, where he won the presidency, but lost in 2020, where he lost the presidency. So if we look at this scatter plot, what's very obvious is that there's a very strong relationship between these two variables. Right, up here in the top right, we've got states that the Democrats did well in, that the Republicans did well in 2016 and 2020. And then down here at the bottom left, we've got states that the Democrats did well in both 2016 and 2020. But most generally, we see there's a very strong relationship between these two variables. I've drawn a red line sort of through them, so you can tell that these points are very close to this line. So drawing this scatter plot tells us something useful about the relationship between the two variables. There's also a related summary statistic here that tells us about is there a good linear relationship between two variables. And that summary statistic is known as the correlation. The correlation is normally called R. I'll call it Rxy because it's the correlation between two variables, x and y. And its formula is this, Sxy over Sxsy, where Sxy is this thing. 1 over n minus 1, sum, sigma notation again, equals 1 to n xi minus x bar being the mean of x, yi minus y bar. so those two things multiply together. That's called the sample covariance sometimes. And Sx and xy are the standard deviations we saw before. Sx being the square root of the sample variance, Sx squared, and Sy being the standard deviation of y, the square root of Sy squared. Those are the standard deviations. And so we calculate those three things and plug them into this formula for Rxy. And that tells us the correlation. One thing that, in fact, you will prove yourself on the problem sheet is that Rxy takes values between -1 and +1. So the biggest it can be is +1, the smallest it can be is -1. If you get a result like +1 or plus 0.9, some very high, close to 1 positive number, that means there's a strong positive relationship. By which I mean that all the points are very close to a straight line with positive gradient. So high values of x are associated with high values of y if the correlation is very close to +1. Similarly, if you get a correlation very close to -1, that tells you there's a strong negative relationship, as in your data points are quite close to a line with a negative gradient. So that says that big values of x are strongly associated with small values of y, whereas big values of y are associated with small values of x. Whereas in the middle, if Rxy is quite close to 0, say plus 0.1 or minus 0.1, that means there isn't really any straight line relationship, no linear relationship. There might be some relationship between x and y, but the correlation tells us whether there's a clear straight line relationship or not. We go back to our election data here. You can see from the picture that there's a very strong straight line relationship. And in fact, if you calculate the correlation, you could do it all on your calculator, but I did it using R, and you can see the commands for that in the notes. We get out here a correlation of Rxy equals 0.99. That's very strong. It's almost as big as it can be. It's almost at +1. That says there's a very strong positive relationship between results between different elections. And so the correlation is our final summary statistic for this section of notes.